Hi, Assalamualaikum and good day to you. Welcome to International Conference on Education, Social Sciences and Engineering ICESE 2021. I'm a researcher from University Malaysia Sabah. My name is Habib Musa bin Mohamad. What I want to share with you today is about post-cyclic. First, I'm going to share with you the abstract of this study. In the next sections, I will show you the introductions of post-cyclic testing on peat soil. The post-cyclic behavior of a peat soil after subjecting to cyclic loading is a major topic in the study and interdisciplinary structured. A serious laboratory monotonic and cyclic correctional test followed by post-cyclic monotonic test carried out to determine the effect of soil behavior when subjected to cyclic loading. Tests were carried out on the undisturbed samples taken from Parit Nipah Peat, Malaysia, and the cyclic traction tests were performed on consolidated unbranched specimens with 50 mm diameter and 100 mm in height. Consequently, followed by monotonic loading. A dynamic traction testing was then used to investigate the unbranched resistance of undisturbed soil samples, and tests were performed under different cyclic effective stress ratios from 50 kPa to 100 kPa with various amplitudes applied from 0.5, 1.0, 1.5 and 2.0 Hz. Monotonic tests were conducted on soil specimens by controlling the strain rate in order to determine the pre-cyclic and post-cyclic shear strength. The index properties of peat specimen is 650% of moisture content, and the fiber content consists of 27.17%, and peat is classified as hemic peat type. In these presentations, I will discuss the introductions of post-cyclic testing, which mainly used to investigate the peat soil behavior when subjected to cyclic loading. In present situation, due to demand and human civilization necessity, large areas of peat soil forests have already been cleared, and due to the conversions to other uses, the conversions of it aim to completely alter the landscape for development policies to take advantages of land use to more productive uses for human activities, settlements, and industry as a result of economic development for Greater Malaysia. Unfortunately, the utilizations of peatland in Malaysia is an optional and compromise because the constructions on marginal land such as peat soil has high economic factor to consider. The behavior of peat soil itself inviting future major problem in the construction industry and related to the post-construction quality and productivity. Peat soil is an organic soil which consists more than 70% of organic matters. Peat deposits are found where conditions are favorable for their formations. According to Uvendran 2007, peat has compared to clay as a complex mechanical behavior, high compressibility, predominance of creep, and shear strength properties which are strongly stress dependent. The post-cyclic behavior of peat soil after subjecting to cyclic loading is presented in this paper. Tests were carried out on the sample birth by allowing the cyclic pore pressure develop during cyclic loading to dissipate and without dissipations, while the sample subjected to post-cyclic monotonic loading without dissipations of cyclic pore pressure. The samples after dissipations of cyclic pore pressure exhibited a normal consolidated behavior. All the samples subjected to cyclic loadings exhibited a lower unbranched shear strength during post-cyclic monotonic days when compared to the samples without prior cyclic loading history. The post-cyclic monotonic shear strengths were evaluated after various numbers of cycles of dynamic loading, according to Erkan and Ulker 2008. and the amount of effective stress increase, the deviated stress also increases with the increasing in axial strength according to Paskowski 2003. In this study, there are three stages of testing were carried out. First, static monotonic loading. Secondly, cyclic loading. And third is post-cyclic loading. At this stage, similar applications to the static monotonic test stage was adopted. Moving on to our next area of interest. Now I would like to discuss the methodology and laboratory testing. All tests have been conducted using undisturbed pit soil specimen. The sampling location was located in Parit Nipah Peat and take as PNPD. Groundwater table was found at the depth of less than 1 meter during the sampling. The soil was excavated to a depth of 0.5 meter below the ground surface, and numbers of tubes sampled with the sizes of 50 mm diameter and 100 mm height were pushed slowly into the soil. The undisturbed pit soils were waxed buff at the end of the tubes and sealed with the aluminiums and plastics to prevent the loss again of moisture. Jolting during transportation was avoided. The samples were kept in the laboratory under constant temperature in the air-conditioned room. Cyclic traction machine, or popularly known as a dynamic traction testing system or LDINT, was used in the determinations of shear strength of PNPD using an electronic control system. Sample preparation for the cyclic traction test is similar to the monotonic test. The test specimens were mounted on the base of the pedestal seal with a rubber membrane at ends will filter paper and porous stones and each other. All samples were collected and consolidated to 50 and 100 kPa effective confining stress, and cyclic tests were performed under different frequencies range of 1 Hz to 2 Hz in order to determine the shear strength by differentiate the cyclic loading and frequencies effects. Index properties test conducted on undisturbed specimen. The cyclic test followed by static loading of all specimen in order to determine the effect of cyclic shear stresses on the static shear strength of Parit Nipah Peat soil. Monotonic loading was seriate applied at 0.10 mm per minute loading rate and lasted till the soil specimen exhibit a shear strength of 20%. The specimen was subjected to 100 cycles for all specimens with different frequency for each sample. The frequencies applied between 1 Hz and 2 Hz respectively after cyclic loading. The specimens were immediately subjected to standard consolidated unrun traction monotonic loading to failure. Since as you can see here, pit soil sample in cylindrical shape was mounted to the bottom pedestal of traction chamber. Sample was then pressurized with 50 kPa and 100 kPa. Sample was cyclically loaded in this chamber with various frequencies from 0.5, 1.0, 1.5, and 2.0 Hz. There are 4 main stages involved in this study. First, sampling was excavated to a depth of 0.5 meter below the ground surface, and numbers of tube samplers with the size of 50 mm diameter and 100 mm height pushed into the soil. Second, pre-cyclic. Samples were consolidated to 50 and 100 kPa effective confining stress and monotonic loading rate with 0.10 mm per minute, which is shear strength about 20%. Third, Cyclic tests were performed under different frequencies range of 1 Hz, 2 Hz, 0.5 and 1.5 Hz in between and subjected to 100 cycles. Fourth, which is similar to monotonic tests at pre-cyclic stage, here is post-cyclic stage, which is loading rate applied is about 0.10 mm per minute with shear strength of 20%, immediately subjected to standard consolidated unrun triaxial monotonic loading to failure. Now, I will share you the results of tested specimens. As seen in Table 1, natural moisture content is 593%, liquid limit 243%, specific gravity 1.3, pH test 4, organic content 95.6, and fiber content 28.5. The index properties of Parit Nipah Peat soil very significant that natural moisture content for Parit Nipah is around 593% and the natural water content of peat in Malaysia ranges from 200% to 700% and with organic content in the range of 50% to 95% according to Huat 2004. Therefore, the recorded values of Parit Nipah Peat soil fulfill this statement. Specific gravity recorded 1.3 were within the range of Huat 2004. In addition to basic characterizations, there is the Parit Nipah peat identified as hemic peat. As you can see in this slide, from figure 1, the effect of cyclic loading on post-cyclic behavior of peat soil specimens at 50 kPa and 100 kPa, which deviate the stress versus actual strain and excess pore water pressure versus axial strain. Effect of cyclic loading of various frequencies and effective stresses on post-cyclic behavior have been monitored in these cases. A comparison of the deviated stress behavior during the post-cyclic test with the stress-strain behavior during monotonic test as presented in figure 1 and the next figure in figure 2 as well. Figure 1 shows the effect of cyclic loading on post-cyclic behavior specimen at 50 kPa and 100 kPa. And in figure 1, represent for Parit Nipah at 50 kPa and 100 kPa. As observed in figure 1, the 50 kPa effective stress and 100 kPa, it showed that high similarity resulted in a significant decreases of deviated stress after cyclic loading in initial or static test results. The shear strength of peat decreased after cyclic loading and nearly 60% losses strength where initial static tests for 50 kPa and 100 kPa are 53.36 kPa and 92.08 kPa respectively. The shear strength decreases noted in sequence patently similar, which 0.5 and 1.0 Hz noted higher than 1.5 and 2.0. The effect of various loading frequencies shows gradually decreases after 1 Hz loading applied, and this is show the higher loading frequencies, the lower shear strength in resulted destruction of fiber in peat soil, confiscated of peat strength. Therefore, the recorded values for PNPD fulfill this statement with Morena and Edgar 2004 statement that different confinement pressures exhibited in a cylindrical in cyclical shear strain range between 0.3% to 1%, a growth on the damping ratio and a shear modulus degradations of 10% at the end of the first 5 cycles of each strain level. From the shear stress and pore pressure perspective, as shown in this figure 2, additionally, it was noticed that in the PNPD or Parit Nipah Peat soil, the excess pore water pressure generation influenced by loading frequencies and generated by strain level that showed decreases strain in figure 2 as well. And Moreno and Edgar 2004 highlighted that the generation of excess pore water pressure depends mainly on the strain level reached and on the cyclic degradation produced, and on a small portions on the increase on the number of cycles. At the end of this study, we can conclude that the undrained behavior of peat soil subjected to cyclic loading significantly show the correlations of static and dynamic loading behavior of undisturbed soil sample. The following results have been observed and obtained during the test, which is number 1, the shear strength decreases noted in sequence patently similar. The effect of various loading frequency shows gradually decrease after 1 Hz loading applied, and this is show the higher loading frequencies, the lower shear strength and resulted destructions of fiber in peat soil confiscated of peat strength. And number 2, the excess of pore water pressure decreases as increases of loading frequencies. Number 3, the excess pore water pressure generation influenced by loading frequencies and generated by strain level that showed decreases strain. And number 4, the pore pressure generation seems to be dependent on the different loading frequencies and rely on shear deformation levels that generated in cyclic loading stage. And number 5, the post-cyclic monotonic test itself show that the effect of cyclic loading degrades undrained shear strength. And number 6, the excess pore water pressure in post-cyclic considerably lower than values developed in monotonic tests. And that brings us to the end. I would like to thank you for your time and attention today. If you require any further information, feel free to contact me at habibmusa@ums.edu.my or through ResearchGate Habib bin Mohamad. Thank you and good day.